Hi folks. In the world of ham radio, old radios like this are affectionately known as boat anchors, hence anchors away. Today I'd like to take a look at this National NC300, so let's get started. The National NC300 has been called the epitome of a boat anchor since it is big, heavy, and bulky. It was manufactured from 1955 to 1958. It was referred to as National's dream receiver and as being extremely sensitive, highly stable, and with exceptional calibration accuracy. Okay, so I have the unit on now. It's been on for some time, warming up here. Normally I wouldn't just power on a radio like this and start testing it, but I acquired this from an estate sale and from a friend of mine who was running that estate sale. So he had already turned it on and verified that it was okay. So we're going to just try testing it out here and see what kind of reception we can get here. I've got it set to AM and to the 160 meter band, which you can see there. And I'm going to inject a signal into the antenna with my signal generator, which I'll show you right here. So that is the Panasonic signal generator, and you can see it's set to 1880, so 1.88 megahertz, in other words. It's doing amplitude modulation. I don't have it set up for amplitude modulation, but I'll turn that on in a second. And then I have a second frequency generator up there, or frequency counter, I'm sorry, that is verifying that indeed it's 1880, just to make sure that I'm on the right frequency there. So I'm going to lower this amplitude here to about minus 60 dBm, and I'm going to turn on the amplitude modulation here, and with a 400 hertz tone.
You're way above our heads.
I'm sure many of you watching this understood what I was doing there, but don't worry if you aren't familiar with terms like modulation or dBm. Basically, I'm just setting up a simulated radio signal and seeing if the radio can receive it. So let's see what we can get if I turn this to receive here. Let's see if we get it around. Yep, there it is. 1880. Well, it's a little bit higher than 1880, but not bad. Cool. Okay, now I've switched to CW mode to try and get a little bit more accurate reading on where that frequency really is. So I've turned off amplitude modulation, and what I'm going to do is try and find the 0 beat frequency.
Hadn't thought of that.
CW mode is normally used for receiving Morse code. CW stands for continuous wave, which means sending a single radio frequency. The operator turns the single radio frequency on and off with the Morse code key to send the dots and dashes, or dits and das, of Morse code. On the receive end in CW mode, you can hear the difference between the received signal frequency and the frequency the radio is tuned to. When the radio is tuned exactly to the receive frequency, the difference is 0 and you don't hear anything. This is referred to as a null. Note that this wouldn't work as well on a modern radio, since modern radios normally correct for the frequency of the side tone when displaying the receive frequency. On this old radio, I can set the side tone to 0 to get an accurate reading. I've got 1.88 megahertz set here again, and let's see if we can find that on this dial here. Right there, where it gets to 0, where you don't hear the sound anymore, that's the frequency where the radio is. So it's a little bit high on this band. Let's try the next band and see where we are on that. So let's try 3.7 megahertz here. Oop, there it is. It's pretty close. It's pretty close. Not bad at all. Next band. Let's try 7.15. Pretty close. Just a little bit high there. Let's try 20 meters here. Let's 14.2. Let's try that. 14.2. Okay, just a little bit low on 20 meters there, but pretty close. Pretty close. And how about 21.2 on this one? Okay, a little bit low on that band too, but not terrible. Okay. And now let's try 27.0. Okay, a little bit high there, but still not bad. Yeah, how about 28.8? Just a touch low. But again, not bad. Not bad at all. Right there. Okay. Now, the 6 meter band, the 2 meter band, and 220 megahertz, the one, that one, those bands are not enabled on these radio because it requires an accessory that's not plugged in here. So those bands won't function. But the rest of these bands are doing pretty well. Not bad at all. So there you go, folks. I think this radio is pretty good to go. I may dig into it a little bit more in the future, try to align it a little better, or check out the components that are inside there. But for now, I think it's pretty good. Thanks for watching.
Beautiful.